Hey guys, we're going to keep on going with inequalities and it's going to be great. Now we're going to go from single steppers to multi-steppers. This is basically the same as our previous lesson, only when we have 2 or more steps in solving the inequality. And all of this is very similar to solving regular equations. Just remember, we have this new rule that we reverse the positive or negative sign when we multiply or divide, specifically those two operations, by a negative. It's not add or subtract by a negative, and it's not multiply or divide by a positive. It's specifically multiply or divide by a negative. Okay, here we go. So if I have this inequality here, I want, of course, to isolate the x. If this were a regular equation, what would you move first? Reverse of a negative 6 is a positive 6. What I do on one side, I do to the other. So 5x is less than 25. I kept that same inequality sign because I did not multiply or divide by a negative. And then to isolate x, it's being multiplied by a 5. The reverse of multiplication is division. What I do on one side, I do to the other. X is less than 5. And again, I kept that sign because while I divided to find my solution, it wasn't by a negative. So I'm going to keep the sign. So to graph, will I have an open or a closed circle? Open, because my solution is x is less than 5, but that doesn't include 5. And then to the left. So that's the inequality, and that is the graph. And as always, we should check our work by substitution. What's less than 5 is 0. That's convenient. 5 zeros is 0, minus 6 is negative 6, and that is less than 19. If you can do that mentally, great, or you can write it out too. That's totally fine. Okay, let's try another one. Now, if this were an equal sign, what's the first step you would take? Instead of subtracting 17, we're going to use inverse operations to get 12 is something 6x. Did I just multiply or divide by a negative? No, I didn't multiply or divide at all, so I'm going to keep that sign. And then to isolate the x, the reverse of multiplication is division. What I do on one side, I do to the other. So 2 is less than or equal to x because when I divided, it was by a positive, not a negative. Now be careful, the variable comes first. And when you do that, remember x was greater than, so x still needs to be greater than 2. So this is your inequality solution. Then your graph, here's the 2. Open or closed? Close. To the left or to the right? To the right. So let's pick a number on the right side of 2 here. How about 10? 6 tens is 60, minus 17 is 43. That's bigger than negative 5 by a long shot. Okay, so far this has been just like solving an equation because I haven't multiplied or divided by a negative number. So now we're going to do that. Okay. Sorry, my papers are getting stuck in my tripod here. Okay, here we go. Negative x is with a positive 9. To take out that negative positive 9, we'll subtract it because positive 9 and negative 9 zero out. Okay, I did not multiply or divide, so this is not where I change the signs. Okay, so if I have a negative x as a solution, we have learned up to this point that if we have a negative variable, we can just make it positive as long as we change the sign on the other side. And we've talked about why, but sometimes we get stuck with the rule and we forget why. Remember, the reason for that is we multiply each side by a negative. And by a negative, because a negative times a negative is a positive, or some people say negative 1, right? Well, when I did that, I multiplied by a negative. See? And so because of that, then I will flip the sign. And so, open circle for negative 5. And which way does the arrow go? Okay. That got a little bit dicey, so it's really wise of us to check our answer. Let's see, negative 6 is smaller than negative 5. Negative 6 is a positive 6. 6 and 9 is 15, and that's greater than 2. So we can know that our answer is correct. All right, let's try another. What happens if we have decimals? Just cry? No. We can handle decimals. Okay. Do I change my sign here? No, I just added. Okay. To isolate the x, divide by the negative 3. 12 divided by 3 is 4, so 0.4. What's my sign now? Like this, because I divided by a negative. So, what is my graph going to be? Open circle or closed? Open. To the right or to the left? To the left. Okay. 0 is less than this, so negative 3 zeros is 0. Negative 4 is greater than negative 8. What went wrong? Ooh, this is why we check our work by substitution. This is also why I don't mind when I make a mistake when I'm recording, because it's really important that we can see by checking our work. We'll catch errors. Do you see it? I see it. A positive divided by a negative is a negative. Haha, that changes things. There we go. Let's try a different one. So a number that is less than negative 0.4 would be like negative 1. Negative 3 times negative 1 is 3. Minus 0.4 is 2.6, and that is greater than 0.8. See? It is really important that you check your work. Even old people who have been doing this for a really long time make mistakes, because it's really easy to fly through and make a silly, simple mistake. Okay, for this back, feel free, especially if you've seen this lesson once, to go ahead of me and pause as needed. You know, go ahead, see what you can do, and then start up again. So I'm just going to blast through and just assume that that's what you're doing from home. Okay. All right, great. So let's see. The first thing to remove is the negative 6 by adding a positive 6. 12 and 16 are 18. 18 is greater than. Good. And then x is being multiplied with a negative 2. Reverse of multiplying is division. What I do on one side, I do the other. Negative 9 something x. What do I do with my sign? Yeah, I flip it because I divided by a negative. What's wrong with my solution? Variable comes first. And remember, if I flip the order, then I have to flip the sign. Okay, and now we graph. Negative 9's in the middle. Open or closed? Open. To the right or to the left? Greater than. 0 is greater than negative 9. Negative 2 zeros is 0. 0 minus 6 is negative 6, and that's less than 12. We are good. Okay, rocking and rolling here. We got it. Here's something that is just a matter of personal preference here. Some people like to bring all the variables to the left and all the constants to the right. Some people like to do what they can to make sure that their variables are always positive so they don't have to flip the sign at the bottom like in the previous question. So it might be a little less work for you to, instead of subtracting 3x to get a negative 4x over here and then having to deal with that negative, it might be wiser to add the x. But you do you. You do whatever you want. If you like to put all the variables to the left, you do that. Okay? I only did addition. I didn't do multiplication or division, so I don't have to worry about flipping my sign. And then I'm going to do this. Again, I didn't flip the sign because I didn't multiply or divide. Negative 1 is greater than x. Is that good? Nope. X is what, negative 1? Less than. Okay, so negative 1 goes here. Open circle or closed circle? Open to the left. Okay. Negative 2 is less than negative 1. Let's see. Negative 2 is 2. 2 minus 4 is negative 2. Negative 2 times 3 is negative 6. Minus 2 is negative 8. Is negative 2 greater than negative 8? Yes, it is. Good job. Well done. One more. Now this one's tricky. Okay. Here's an argument. you just take a second and you see where the argument's going to come up, first of all. So you see it? We see parentheses and we see distributive property. And for the distributive property, we, in essence, are multiplying the outside number with the inside because this is negative 2 groups of this. So we simplify that so that we can solve by multiplying and by multiplying. So my question to you is this. I multiplied by a negative 2. Does that change the order of the sign? Or does that change the direction of the sign? Because I multiplied by a negative. Okay, it does not change the direction of the sign. These two are equivalent. They have the same value. Okay, I didn't change or undo my signs here. Okay, I'm not isolating anything. I'm not solving. I'm just finding a different value of this expression so that I can work with it. I only reordered the left side and not the right side. So when we change the sign, it's if we are multiplying or dividing both sides, not using the distributive property. All right, and then let's see. I don't want negativity in my life. I try to keep it far from me if possible. And then, am I going to get a fraction for a solution? That's awesome. Are we afraid of fractions? No, we're not. If you said yes, stop it. 1/6 is less than or equal to x. I divided here, but I did not divide by a negative. What's wrong with my answer? Yep, flip it. Okay, so 1/6. Open or closed? Closed. To the right or to the left? To the right. Kaboom. Okay. A number bigger than 1/6 is 1. Keep it easy. 1 and 3 are 4 times negative 2 is negative 8. 4 ones is 4 minus 3 is, I just lost my mind. Negative 3. Whew. Is negative 8 less than or equal to negative 3? Yes, it is. Cool. All right. So do you see how it's exactly the same as the previous lesson, just with multi-steppers? It's just like solving an equation, except for that one rule. It's really important. Really, really important. But if you can remember that one rule and apply it to what we did clear back in chapter 3, you're going to be good. You're going to be fine. Okay. So let's review your homework because this is actually a good practice for you. Hopefully it'll be easy for you. I hope. Yeah. Okay, so these are kind of leveled for you. There's some simpler ones and there are some slightly more difficult ones, but I don't even think those are really difficult. You're just solving the inequality. For this one, I won't make you graph it as well. That's not really my major priority in this one. Of course, it's good for you to be able to graph it, but I'm going to flip to the other side so that we can do some examples and not steal from your homework questions. So if you can please show your work on a separate piece of paper, that would be great, because it becomes a little much to do all in your head. And so you'll just solve do-do-do. This is fun. 49. And I'm going to divide by a positive. So when I divide by a positive, it keeps the sign just how it is. X is less than 7. And a number that's less than 7 is 5. 7 5s is 35. 35 minus 30 is 5. 5 is less than 19. So I can be confident in my answer and say on the worksheet, X is less than 7. That's all you do. Got it? Okay. I'm not going to steal too many more of your questions because I think you'll be just fine. Remember to refer to our last question in our notes with the negative that you're distributing inside of the parentheses. Again, that does not change your sign. If you multiply or divide both sides by a negative, then you change your sign. And I would like to have you do question number 22. and I would like to just give you a little bit of a head start with it. It says an amusement park charges $32 for admission and $6 to park your car. Wow, times have changed. It costs a lot more than that to park your car at Six Flags. Write an inequality that represents the possible number of people that could go for $166. So let's pretend you have 166 bucks. You want to know how many friends you can take with you. I'm assuming you're taking a bus because there's an unlimited number of seats. We'll find out what size of a vehicle we actually need, but I just want to, clear up the particulars here. So what's the maximum number of people that can go? So ask yourself, what am I comparing? I'm comparing the 166 that I have with the cost for whatever my situation is. So I'm comparing it with the cost. Don't know what that is yet. Okay. And my $166 can be the same. That would be nice, but then you don't have anything extra for like a funnel cake later. Or the cost for all of this needs to be smaller than that. Okay. Now, what do we do for the cost? Well, we have a constant. What is our constant? We're constantly being charged how much per person? And then we also have to consider what fee? That was $6, right? I'm not going to write that in there. I want you to do that. Factor in that $6 to park your car. And then solve the inequality to determine how many people you can possibly take for $166. You can also determine what size of a car you have to take. Okay. I'll give you a hint. You do not have to take a school bus. Or I'm just gonna stop. Okay, great. Hopefully that helped. Ooh, if it didn't, come see me. Or send me an email. Oh, I didn't do my disclaimer at the beginning. I'm sorry. I hope you liked this lesson, but it's not the perfect one. It's just the highlights, not exactly what we do in class. It's enough to help you at home. Different math teachers will do it a different way, and that's okay. But I hope it was helpful to you today. Thanks, guys, and I'll see you in class. Bye.